Thank you, everyone. So I'm going to talk about a lot of stuff. As David mentioned, we're talking about technology, we're talking about organizations, we're talking about people, we're talking about business. So it's power your moonshot with the cloud. And when we talk about sort of moonshots, what it means at Google, for example, is how we take a huge problem or a massive sort of need, and with breakthrough technology and radical solution, we solve it. And in the intersection of all those three elements is what we call at Google, Google X. And they've spun off a few of these innovations from driverless cars to virtual reality and other things as well. But it's not just Google X, it's not just Google, and it's not just technology companies that have to moonshot and to innovate in order to stay ahead of their game. Nowadays, any organization in any sort of vertical, whether it's retail or anything else, need to know how to innovate and how to take advantage of the resources in order to stay in the game. Because what we know for sure, the strong, predictable thing we know, is that the world is unpredictable. So technology, who's the trigger of a lot of this change, is changing. People are changing as a result, businesses are changing, the world is changing, and organizations are required to change with it. Because when we talk about transformation, many people talk about digital transformation, because everything really starts with the technology. It enables us to do things differently. But there's also the business transformation. As a result of the technology, part of it is the cloud, we can do more business model innovation. New opportunities come into play. And obviously, it's a cultural transformation as well, because eventually it's all about the people and how we empower them to do excellent work. So when you do any sort of transformation and you think about how to leverage technology, you really look through those four areas of technology, people, business, or an organization. Technology being the main trigger of it, people being the ones that are implementing it. Without them, there's nothing. Business is the main recipients, and organizations are required to change. And then there's a lot of other triggers, anything from sort of data mobile, the fact that the workforce today is virtual. Everybody's working from across the world, and we need to make it work. Now, when we think about innovation, many people have these words sort of in mind: non-conformity, change, open. But in some cases, when you think about corporations, these words are not synonymous. It's more predictable. They like the business as usual. So one of the challenges that you have with innovation is almost like a standoff, right? On the one hand, you want innovation, but on the other hand, you have sort of cooperation. And it's that sort of tension that sometimes, again, triggers what people call digital transformation, which is not just about technology. There's a lot of other management practices in play, such as agile and lean, that help organizations transform. And these are a lot of sort of questions that we at Google Cloud are being sort of asked. How to modernize the infrastructure, how to get insights from data, and very importantly, how do we partner in the cloud? And that's how pretty much we've structured Google Cloud. So on the back end, a very sort of powerful infrastructure to enable everyone to develop applications and to have all the storage and computing power needed. And all this, so on the front end, the organizations can work as productively as possible, knowing that people's desires and the way they work is changing, and ensuring that they have the right application to be productive and connected globally. And looking more into our back end, over the past few years, the Google Cloud has expanded, with our global network expanding into sort of multiple regions. And this is an example of one data center. Each one of these buildings is a different sort of zone, and each size of that is equivalent to a football stadium. So we're talking massive, massive investment in infrastructure. In addition to that, Google has spent a lot of time of innovating different sort of technologies on the back end, writing white paper and keeping it, as the speaker before me said, extremely sort of open. Latest would be sort of the Kubernetes and TensorFlow, the machine learning library. And on the front end, going back again, there's also innovation over there, because it's not just providing the best-in-class infrastructure, it's ensuring that the organization can work. And an example would be sort of real-time collaboration on docs, and obviously the smart reply and compose that's open to everyone on Gmail. And in addition to that, on both back-end and front-end, a layered defense in depth security, best engineers working on it because it's a constant sort of work. It's not a one-time fix. as I'm sure you know. And that helped us reach more than 5 million users or customers on G Suite and over 1 billion users on GCP. So people come to Google Cloud so we can work on innovation. And when we talk about Google Cloud, we need to talk a little bit about Google. So Google is the G of our parent company, Alphabet, the restructuring that happened a few years back. And in Alphabet, we've got other companies, such as Google X, Next, DeepMind. Some of them have obviously spun off, so like Waymo. And going back into Google, started off as a research project back in Stanford University, Larry and Sergey over there. And early on, it was very much an agile sort of company. So this is one of their first servers using Lego bricks in order to keep it working. And this is Google now, in 1998. Obviously now it looks a bit different. The other sort of unique thing with the Google culture, it's not been great at creating innovation. It's been great at nurturing innovation over the past sort of 20 years. Some of it in-house, some of it obviously bought as well. So when you guys think about Google, many people think about this, right? But it's important to understand that behind this, there's a massive operation going on, massive infrastructure to ensure that everybody across here, the ones that are looking at me and the ones that are searching on the computer, can have that access. And that helped us reach over 1 billion users across 8 sort of products. So when we think about scale, technology, and enabling that, we have a lot of sort of experience, obviously, over there. So let's now go back to the market and understand a little bit of the disruption that we're seeing from 3 key areas that have been emotive so far. From the technology perspective, the people, and the business. From a technology, what we're seeing is that there's more data out there. This is from a Cisco report, and it's just expanding. People are using mobile. And behind this technology, we obviously have the cloud. When we look about data, one of the key things, or the driver of data, is obviously smart devices, and they're just going to expand from simple things that we use in our home all the way entering into real organizations for various sort of needs. And that will lead us, in a few years' time, to a massive, massive amount of data. Now, why is that important? Because if you look at it from the studies, the unstructured data, the photos, the videos, the text, it's not really being used to drive any sort of business decision. But not only that, even the structured data, in tabular format that you can easily query, is also not driving decision. And that's why it's not just technology that needs to happen in order to resolve this transformation and really take advantage and leverage the ability to insight. From a mobile perspective, I'm sure you all know, and this is just from October 2016, most of the traffic is going via mobile, and it continues. Cloud, obviously, it's all about abstraction, making it easy for organizations and people to focus on what they do best, which is key, and let sort of others solve the issues of the servers, the networking, the security. And obviously, there's different elements of cost, agility, and advantages of using the cloud. So these 3 technologies together have actually brought together, and they were necessary to bring artificial intelligence. Not a new technology, but something that was not really applicable before you had the abundance of data, the computing power and storage to use it for, and obviously people requesting it. And Google is very much an AI company, something that our CEO publicly mentioned, and this information or these machine learnings are injected into a lot of our products as well. And it's the same sort of machine learning algorithm, it's the same sort of infrastructure that supports the key products that many of us use. It's the same infrastructure that you can have access to also via the Google Cloud. Now let's stop for a minute. As David mentioned, I am studying neuroscience, so I thought this might be interesting to you guys. Let's try. When we think about intelligence, let's try sort of to break that down, again, using some abstraction, and try to compare between the human, biological or evolution-inspired intelligence and the artificial or technological-inspired. First thing, let's look about human. Human intelligence is what we call sort of general. I can speak with you guys right now. I can move my arms, I can stand, I have different thoughts. Some of you may know what I'm thinking about, some will not. And that's a multiple dimension sort of intelligence. In addition, there's emotion, which sometimes is a positive thing, sometimes a negative, which can be strategic, abstractions, and more. From a machine perspective, it's very much a narrow artificial intelligence. It's for a specific task or a problem. It can drive your car, or it can recommend you videos on YouTube, but it can't do both. And that's the sort of the key difference to understand. The other things from a human learning, there's something called the reward pathway, something that humans share with most of the animal kingdom. And this is when the body provides the brain a positive signals for things that it does good, like eating, breathing, sleeping, for example. That's sort of the dopamine, using that chemical. But obviously, as mammals evolved, we have also the frontal cortex to ensure that we modulate that, so we don't eat ourselves to death, for example. If we look from a machine learning perspective, the similarities with reinforced learning, and we'll see an example of it soon. And lastly, looking about the technology for machine learning, we have artificial neural networks, which is very much loosely inspired of biological neural networks that you see an example of a neuron. In the brain, we have 87 billion of those, each one with 30,000 inputs and outputs with other neurons, making over 1,000 trillion connections. Artificial intelligence is trying to kind of mimic that through mathematical equation. And that has actually led sort of to computational neuroscience, which is looking for biological, plausible mathematical models to get what we have over here. Now, you may ask yourself, why are we talking about, the brain when we're talking about artificial intelligence in a tech conference? It is our own sort of Ray Kurzweil mentioned that the best way to do that, to understand machine learning and to build it, is to understand human intelligence. And there is actually one project that Google is helping with, and that's to try to map those different connections that I explained before in the brain. It requires a lot of computing power and so on, and we've been actually getting a few innovations as a result. And if some of you have watched the news from last night, again, Jeff Hinton, who's also a Googler, along with 3 others, won sort of the Turing Award for his work on artificial neural networks. So how does that work? Let's briefly look at his work. First step is to do the training. Second step is to do the testing with a probability, and as you test more and you train more, that probability increases of, for example, identifying if it's a cat or a dog. Sounds simple enough, right? But obviously there are examples when this becomes a little bit more complicated for the machine, such as in this case. What about this case? Easy, right? Not necessarily. So depending what dog you have. And there's been a few articles on some of the other work that Google has done on machine learning. One of my favorite things is this thing. This is a partnership with Stanford University. And what they do over here is they scan skin cancer sort of lesions. So on the left-hand side, what you see is a malignant lesion with 98% probability. On the right-hand side, something which probably is benign. Now, there are 4 key points that I want to mention over here when it comes to sort of machine learning, replacing people, not replacing people, and so on and so forth. First, let's talk about numbers. If you're a physician, and you've been a physician all your career, you've gone through what? 1,000 cases? Maybe even more, you've read about more, let's say 5,000 cases. The algorithm can run through millions in a matter of a week. So the question is, who is more experienced? And as I mentioned before, human intelligence has its advantages, but disadvantages. If the physician has a bad day and his mind is preoccupied, he may miss something as well. And when you think about access to healthcare across the world, not a lot of people have that. That can potentially help and also reduce the load in other parts of the world. And the key thing over here that this is not a replacement. This is augmentation of humans with the machine in order to get sort of the better results. And there's other applications for machine learning, anything from cooling down data centers, translating, and so on and so forth. Now, I don't know if some of you have watched sort of this video before, but this is from DeepMind, the company that Google acquired. And they also demonstrate how a machine learning algorithm can learn pretty fast after just one night of training. So I'll roll the video and let you watch.
This is before the first time the AI has ever seen this data stream. So don't forget, it doesn't know what it's playing, it doesn't know what it's controlling, and you can see it's actually losing its 3 lives. It's controlling the rocket here at the bottom of the screen, and it's losing its 3 lives immediately because it doesn't know what it's doing. But after you leave it playing overnight on a single GPU machine, you come back the next day, and now it's superhuman at the game. It's learned for itself through experience how to play. So you can see now every single shot it fires hits something. It can't be killed anymore. It's worked out that the pink mothership that comes across the top of the screen in a second is worth the most number of points. And it does these amazingly accurate shots to do that. And you can, if those of you remember Space Invaders, as there's less of them on the screen, they go faster. And just watch the last shot that it does, the rocket does. There's this predictive shot to hit the last Space Invader. So you can see how...
And if you think of it, artificial intelligence came to the public domain with games. This is the famous game between Garry Kasparov that he lost. Now, he actually came to Google a few years ago and he talked about that game. And his sort of anecdote and experience from that was that whilst playing the game of chess, the computer that he played against crashed twice. So it had to restart, he had to wait. And according to him, this should have been considered his win. But it was never sort of the case. He still appreciates the fact that nowadays even a small application on a phone can beat him in chess. Obviously after that we had Jeopardy as well. And recently we had, again, Google DeepMind with AlphaGo beating Lee Sedol in the game of Go. And there was one thing that I want to highlight from that game, and something which is called Move 37. That game that was played in South Korea was live streamed across the world. You had commentators just like you had any sort of sports. And look at the response of the commentators when the algorithm made a very unexpected sort of move.
Ooh. That's a very surprising move.
I thought it was a mistake.
Well, I thought it was a click miss, but
a clicko. And if we were online Go, we'd call it a clicko.
Yeah, it's a very strange.
So it was very strange, but that move actually led the machine or the algorithm sort of to win that game, which leads us to believe whether you call it gut feel, whether you call it sort of machine creativity. It really depends on the definition. But maybe there's a path, something that eluded, humans that have been playing the game of Go for thousands of years, that actually the machine saw a pattern in, and we can use that in the future. Now, obviously, driverless cars is a big thing as well. And this is an example of the technology being used and how it sees all across the car, all around the car, and how complex it is when we get into sort of an urban environment as well. And obviously, as I mentioned before, the world is unpredictable. And this is what some of the guys that have tested the car back in the days have encountered in Mountain View.
Just a couple of months ago, our vehicles were driving through Mountain View, and this is what we encountered. This is a woman in an electric wheelchair chasing a duck in circles on the road. Now,
everything is possible. From a people perspective, we're more urbanized, we're more social, and when we're thinking in the workplace, employees are changing as well. So the motivation, for example, the needs, everything is changing. People are looking for purpose, impact, and in terms of hours, workplace, and tenor, they're completely different. You add to that also the gig economy, and we're talking about a different way of working, and organizations obviously are required to adapt. From a business perspective, just look at this, for example. In 1955, out of the 500 companies that made up the Fortune 500, take a few years forward, only 61 sort of remain, meaning 399 new. So all this is hitting organizations, and it forcing them to change the way they work, to leverage technology, and to empower sort of their people. And this is again from the last report of the growth drivers. So if you think of the pre-18th century, it was more of cultivation and extraction. In the 20th century, more manufacturing and industry. And on the 21st century, we currently sort of live, it's computing power, and that's where sort of the cloud and technology really comes in, but also human potential. And if there's one thing that artificial intelligence and machine learning has taught us, is understanding more about sort of what makes us human and the advantages that it has. And just kind of to summarize and to finish off, this is a nice quote that I found, which is one of the key things that we need to adapt and be able to do in the future is to be able to learn, unlearn, and relearn as we sort of continue in the workplace. So, to finalize, here at Google, we're sort of very happy to be sort of in this conference, meeting a lot of you, understanding your innovation, the business, the challenges, and looking to our past in order to work together and build for the future. And with that, thank you very much for your attention. I'm done. Thank you.